Hi, welcome to another FLEETtv episode. My name is Andrea, and I'm the Fleet's Adult Programs Manager, and I'm sending you sunny greetings from La Mesa. I love the San Diego weather. We have so much sun to enjoy. Lauren has a great activity, especially for our young learners, to observe the wind in their home. So Lauren, take it away.
Look or step outside today. Is it a windy day? How do you know? Today we're going to talk about a very special type of weather. Wind! You guys, windy days can be awesome and lovely, but sometimes wind can get really strong, like a hurricane. But what even is wind? How is it created? Let's find out. Now, boys and girls, put your hands up like this and blow. Look, you just created wind. Wind is definitely wacky weather. We can't even see it. But we do see things being moved by the wind, right? Like leaves on a tree or clouds in the sky. What about sailboats in the sea and flags moving? Wind in our atmosphere is created when air heats up and rises and then cools down and falls. Meteorologists sometimes use a special tool called a windsock to measure which direction the wind is blowing. Pilots use windsocks at the airport to find the direction of the wind during takeoff and landing. Windsocks can be very important tools for meteorologists to study the direction of the wind. So today, you guys, we're going to be making our very own windsocks to study the wind in our very own backyards. Well, I hope it's a little windy out today because we're going to be making our very own windsocks at home. This activity is a lot of fun and can be made with a whole bunch of different materials too, making it a great at-home activity. Feel free to get as creative as you want. Today, these are the materials I'll be using to make my very own windsock at home. I have a toilet paper roll, some tissue paper that I've cut up into little strips, tape, string. Let's make our windsock. Once you attach the tissue paper strips to the bottom of your toilet paper roll, you can begin to decorate. Now that I have my windsock all decorated, I'm going to tie a string to the top. You can also use a strip of cardstock paper or construction paper to make a handle. I'll tie this string, and then once it's all ready to go, we're going to head outside and hang it up.
Thanks, Lauren. That was great. I can't wait to make my own windsock and hang it in the yard. I don't miss the rain in San Diego, but there's one thing I do miss, and those are the rainbows, because after the rain comes the rainbow. And we have Jordan, a student from SDSU here, to help us understand why we always see the same colors in the rainbow. Take it away, Jordan.
Hi everyone, my name is Jordan and I'm an astronomy student at San Diego State University, and the question that I got is, why do rainbows always have the same sequence of colors? So to understand this question, we need to know a little bit about how light works. So the light that we see around us, the light that comes from the sun, is usually called white light because it has all of the colors in it. And each of these colors have their own respective wavelength. The red wavelengths are a little bit longer, and the same with yellow, they get a little bit shorter and shorter and shorter until you get to blue and purple when they get really, really wiggly. And this becomes very important when we're talking about refraction. Now, when it comes to refraction, the best way to explain that is, I know it's kind of a big word, but the way that I learned how to do it is with a lawnmower. So let's say that you're walking along on a sidewalk, just some random sidewalk, with your lawnmower, and one of your wheels hits the grass. That wheel slows down. So since the other wheel is going faster, you're pushing it, causing it to turn, and it goes into the grass. Now, if you're walking a little bit faster, the speed difference between the one wheel and the other causes it to turn more, causing you to move into the grass a lot more. Now, the same thing happens with light, but it's not with speed this time, it's with the wavelength. So when Your light comes into contact with something like a water droplet. Each one of these wavelengths turns a little bit more than the other, causing each one of these to separate. And since they're connected and they're always in this order, they always have the same wavelength, they end up looking exactly the same in the sky with every single rainbow that you see. That's why they're always in the same order.
Thanks, Jordan. That was great. Thanks all for joining us again, and I hope to see you next week. If you enjoyed this episode, please be sure to follow us on social media. Bye.